So, dear students, yesterday I already said to you about the introduction part of this sets chapter. I hope you understand that well. And today I want to explain the sums, do this, try this, think and discuss, as well as exercise sums in this chapter to you. Okay, first of all I want to start from the first paper of your sets chapter, that is 25th paper in your textbook. In that there is a do this is there. Already I explained to you about this teeth, the set of teeth, right? So here he asked that list the teeth under each of the following type. There are already, I said to you, no, that is 4 types of teeth we have. So half this 32 teeth, totally we will get 32 teeth. Half. So how many number of teeth, incisors, canines, premolars and molars we have, right? So I'll explain from by using of this gentle formula, that is 2 1 2 3, that is 2 incisors, 1 canine, 2 premolars and 3 molars. So by using of this formula, we have the solution for this. The solution for this do this is the central incisors. First of all, I'll explain about the central incisors. That is, what is the number for the incisors? That is 2, right? So the dental formula you have to find out, you have to remind that is dental formula is 2 1 2 3, right? So incisors, that is 2, right? The central incisors is equal to total 4, that is 2 plus 2. Central incisors 2 plus 2, that is 4. And here there is a figure, you just look after here, central incisors are 4 we have from the upper jaw and the lower jaw. Just like that, lateral incisors or 4. Total we have 8 teeth, 8 incisors type teeth. Okay, just like that, canines. The formula, in this formula there is 1. So canines, total and canines are from upper jaw and lower jaw. Total canines from the upper jaw and the lower jaw, that is equal to 1 plus 1 2. Plus upper jaw plus lower jaw, no, hence 2 plus 2 is equal to 4. Okay, 2 plus 2 is equal to 4. Just like that, premolars. Look at the figure while you are doing this sum. Okay, look at the figure where there is a figure in your textbook. Look at the figure and just watch this solution. First premolars or 4, second premolars or 4, that is total we have 8 premolars. 8 premolars. About the molars, from the formula premolars are 2 here, from the formula, dental formula. Molars 3, right? 3 types. So first molars is equal to 4, second molars is equal to 4, third molars is equal to 4. Total we have 12 molars. How many incisors we get here? 8. Set of teeth is equal to total, right? Set of teeth, that is 8 plus 4 plus 8 plus 12. So total 8 plus 4 12, 12 plus 8 30, 20, 20 plus 12 32 teeth. Okay, it is a solution for the first to do this. Now it is page number 26. So do this. So identify and write the common property of the following collections. Right? We have to write the common property of this collection. Okay? Do this. So what is the common property of this one? The first, he was given that 2, 4, 6, 8 and so on. What are these numbers? Even numbers, right? Even numbers. So the solution is, the given all are even numbers. So in set builder form, how can we write this one? In set builder form, how can we write this one? Set of x colon x is an even numbers. That is a common property of all these numbers. And the second sum, what he was giving? 2, 3, 5, 7, 11 and so on. Right? What are these numbers? These all are prime numbers. Prime numbers. Already I said yesterday about the prime numbers. Only the prime numbers have only there are two factors, that is 1 and by itself. 1 and by itself. Only these numbers which have only two factors. That is the common property are all are prime numbers. That is x colon x is a prime numbers. It is the common property. Okay, let's go to the third one. Third sum, what he was giving here, that is 1, 4, 9, 16 and so on. So look at here carefully. The solution is 1 square comma 4 means we can write it as 2 square. Just like 9 we can write it as 3 square. Just like that, 4 square and so on. These all are the given numbers are the squares of the natural numbers. Is it right? The squares of the natural numbers, and also we call it as a perfect squares. Perfect squares. Here the solution is, here all are squares of natural numbers. Also the perfect squares, right? In set builder form we can write it as x colon x is a perfect squares. And the fourth sum, what he was given here, January, February, March and so on, right? What are these? What is the common property here? These all are months of a year. Months of a year. And in set builder form we can write it as x colon x is a months of a year, right? Next, fifth one, what he was given here, thumb, index finger, middle finger, ring finger, pinky. What he was given? It is, right, it is thumb, it is thumb, and it is index finger, it is index finger, it is middle finger, right, and it is ring finger, it is ring finger, and it is pinky, right. These all are the fingers of our hand, fingers of our hand. So all are fingers of a hand, and x colon x, curl bracket start x colon x, is a finger of a hand. It was a common property, right. Here the first to do this is completed in this paper. Okay, now we will go to think and discuss. In the same page he was given that think and discuss, that is observe the following collections and prepare as many as generalized statements you can describing their more properties. Yeah, వీటి ద్వారా how many describing, how many generalizing statements you can give for this numbers, and just like the do this itself. So we can generalize this sum as 2, 4, 6, 8 and so on, right. This is the sum he was given here. That is, these all are even numbers. First, these all are even numbers. So first generalizing property is all are even numbers. Second generalizing property, what these numbers are, all are even positive integers. Even positive integers. Positive integers, that is even. That is second generalizing property. And the third generalizing property is, these are the squares or multiples of 2, right. All are multiples of 2. So just like that you have to generalize the numbers, what the common property they have, right. And the second sum, it is solution for this one, and the second sum 1, 4, 9, 16 and so on. Already I said in the above do this, right. That is, what is the general property of this one, 1 square, 2 square, 3 square, 4 square. We can convert these numbers into like this. So what is the common property of this one, all are squares of natural numbers. Or all are perfect squares. These are the solutions for this think and discuss. Now we will go to the page number 27. In the 27 he was given that do this, right. Do this in page number 27. Okay, look at here. I'll write the solutions for this. Already I said to you what is meaning of this set. So write the following sets. What he was given in this question, write the following sets. We have to write the sets for this statements. The first question he was given here, that is set of first 5 positive integers. Look at here. So set of first 5 positive integers. First 5 positive integers. Positive integers means what? So integers means we know that is z is equal to, there are negative numbers, 0 including positive numbers. In that we have to take only positive numbers. That is, the positive integers are 1, 2, 3 and so on. First 5 positive integers, set of first 5 positive integers is equal to set of 1, 2, 3, 4, 5. That's it. It is the solution. And the second sum, set of multiples of 5 were or more than 100 and less than 125. Less than 125. Multiples of 5 he was given here. Multiples of 5 that are more than 100. More than 100. So what are multiples of 5? Multiples of 5 are 5, 10, 15, 20 and so on, just like that. But we have to write more than 100. More than 100 means, so more than 100 means the multiples of 5 more than 100, that is equal to, so multiples of 5 more than 100. More than 100 means, so 105, 110, 115, 120 and less than. Don't write this 125, less than. And don't write this 100. Why? Because it is more than. More than 100 means not 100. More than 100. Less than 125. Less than 125, 120. That's it. It is the solution. Right? Third question. Set of first 5 cubic numbers. First 5 cubic numbers. So first 5 cubic numbers we have to write. First of all, write the natural numbers. So the set of natural numbers is equal to 1, 2, 3, 4, 5 and so on. But only we want 5. That is, first 5 cubic numbers are the cubic numbers is equal to 1 cube, 2 cube, 3 cube, just like that. First 5 cubic numbers is equal to 1 cube means 1 cube, 2 cube, 3 cube, 4 cube, 5 cube. That is equal to set of 1 cube means 1, 2 cube means 2 2's 4, 4 2's 8, just like that. 3 cube means 27, just 4 cube means 64 and 5 cube means 125. It is the solution for the third one. And the fourth one, set of digits in the Ramanujan number. The Ramanujan number is, you know, the Ramanujan number. The Ramanujan number is 1729. This number we called as Ramanujan number. Why? Because this number is the smallest number that gives the sum of two cubes is the solution for this 1729. Okay, Ramanujan number. This number we called as Ramanujan number. So the set of Ramanujan number is equal to set of 1, 7, 2, 9. It is the solution. Okay. So let's go to the next phase, that is 28, that is do these problems. Okay, do this in page 28. So question, some numbers are given below. Some numbers are given below. Decide the numbers to which number set they belong to and does not belong to, belongs to and does not belongs to. Already we know that the belongs to is identified with this, right? Yesterday in the introduction part I said to you, and does not belongs to is identified like this, right? So just like that, you have to identify the given numbers, or which number system it was belongs to and which number system it was not belongs to. We have to identify by using of these symbols. Okay, the first number he was given here, that is 1. For which system, for which number system it was belongs to? For natural numbers, whole numbers, integers, we know that, right? At least only one you can write it. That is 1, it is belongs to natural numbers. And which is not belongs to also we have to write, that is solution. 1 is belongs to natural numbers and 1 is belongs to whole numbers. Whatever you want, you just write it, at least 1. That's it, enough, right? 1 is not belongs to. For which kind of numbers 1 is not belongs to? That is 1 is not belongs to irrational numbers. That is irrational numbers is identified like this, right? Irrational numbers. Then 2, that is 0. Solution. So 0 is belongs to whole numbers. Is 0 is belongs to natural numbers? No, is not belongs to natural numbers. Okay, third one, it's a simple answers. Already I said to you, sets is the very beautiful chapter, and we can solve these problems in the very easy manner. Okay, you will enjoy while doing these problems. Okay, very simple solutions for this chapter. That's why I'll start this chapter first. That is -4. The next number he was given as -4. The solution for this -4 is belongs to integers I or z, right? -4 is does not belongs to whole numbers. Fourth one, 5/6. 5/6, it is in the form of p/q, right? In the first chapter you learned about these rational numbers, that is in p/q form. So now 5/6 is a p/q form. So hence 5/6 is belongs to rational numbers, and 5/6 is does not belongs to natural numbers, does not belongs to whole numbers, does not belongs to integers. Whatever you want you can write here, right? That is natural numbers. Fifth number, that is 1.3 bar. 1.3 bar. We can write this number as 1.3333 and so on, right? So we can convert this number into p/q form. In your 9th standard you learned about this kind of sums. You can convert this into a p/q form. Okay, how I show you here. This box, you just take this number as x is equal to 1.333 and so on. How many numbers are there after this decimal? Only one, it is repeated. That is that's why just 10x, 10 into the first equation is divided into 10. So 13.13, which comes before, right? That is 333 and so on. You just subtract equation 2, equation 1 from equation 2. Equation 2 minus equation 1, that is equal to 10x is equal to 13.333 and so on. Equation 1, that is equal to 1.333 and so on. 3's you cancelled here. So from 13 minus 1, that is 12, that is equal to 9x. X is equal to 12/9. So it was converted into p/q form, right? So p/q form, it converts into p/q form, that is equal to 12/9. That is equal to 12/9. So hence the solution is 12/9 belongs to rational number, and 12 by 9 is does not belongs to whole numbers or natural numbers or integers. Whatever you want you can write. Okay, sixth one, that is root 2. We can't solve these single numbers, right? Root 2 is a third. Root 2 is a irrational number. Root 2 is an irrational number. Solution is root 2 is belongs to irrational numbers, and root 2 is does not belongs to any natural numbers, whole numbers or integers or rational numbers. Seventh solution, that is log 2. Log 2 value we have after the decimal. We have so many numbers which is terminating and non-terminating decimals, right? So log 2 is belongs to irrational numbers, and log 2 is does not belongs to whole numbers. Log 2 does not belongs to whole numbers. So eighth solution, that is 0.03. We can write this number as 3 by 100. After decimal we have two numbers, no? That's why we can write this number as 3 by 100. It is in the form of p by q. So this number belongs to, so that implies 3 by 10 belongs to q, okay, and does not belongs to 3 by 100 does not belongs to natural numbers. And the next one, that is ninth sum, that is pi. Pi already we know that 22 by 7, and also this number does not stops, and so on, right? So pi which is belongs to rational number, which does not belongs to whole numbers. So 10th sum, that is square root of minus 4. Square root of minus 4. In the square roots, if there is a negative numbers, these all are, we call it as an imaginary numbers. So square root of minus 4 is belongs to imaginary numbers, and square root of minus 4 does not belongs to natural numbers. Okay, here we completed the do this. Now we finished this do this, no? Then think and discuss. Here the question was, can you write a set of rational numbers listing elements in it? Means, so the question is, he was asking that, can you write set of rational numbers listing elements in it? No. Why? Because there are so many infinite rational numbers are there. We can't list out that all the elements in a set. Okay, so we can't list all elements in the set of rational numbers. Why? Because the rational numbers are infinite. Rational numbers are infinite. Okay, it is the solution for this question. Next, we will enter into the page number 29. Page number 29. Here, look after here. This table which explains about the difference between the set roster form and the set builder form. This roster form we also call it as listed form. So here in the box, look at here, V is equal to A, E, I, O, U. What are these elements? A, E, I, O, E means, I, O, U means, that is the vowels of an English alphabets, right? So in the set builder form, how can we convert this listed form into set builder form? V is equal to set of x colon x is an oval in the English alphabet. Okay, so A is equal to set of -2, -1, 0, 1, 2. And how can we convert the set builder form? A is equal to, what are these numbers? Integers, but which starts from -2 and ends with 2. So only the limited elements are there here in this given set, right? Hence the set builder form, we can write it as x colon x, -2 is less than or equal to x is less than or equal to 2. -2 is there and 2 is there. That's why we can write this equal to, less than or equal to, less than or equal to. And these numbers are integers. That's why x belongs to z. Z is a symbol for the integers. And then the third one in the box, that is b is equal to 1, 1/2, 1/3, 1/4, 1/5. These are the numbers he was given here. But we can write this 1 is also in the form of 1/1, right? So look at here. You can conclude this as, in the denominator we have 1, 2, 3, 4, 5. In the numerator all are ones. In the denominators we have 1, 2, 3, 4, 5. So these all are natural numbers. We know that, right? So b is equal to, how can we convert into the set builder form? That is x colon x is equal to 1/n. Then what is n? Natural numbers. That is n belongs to natural numbers. And up to where? Up to which number the set is ended? That is up to this less than or equal to 5. 5. And the fourth one, that is c is equal to 2, 5, 10, 70. These are the numbers. When we are looking this, we can't assume what are these numbers, right? But look at here, what is the solution he was given here, that is in the set builder form, that is c is equal to x colon x is equal to n square plus 1. N means natural numbers. Look at the solution I will give here, that is in the set builder form he was taking as x is equal to n square plus 1, right? So here n is equal to natural numbers. Natural numbers means 1, 2, 3, 4 and so on, right? And so on. When you substitute this 1, 2, 3, 4 in this given formula, what the numbers we get, right? Look at here. If n is equal to, for example, if n is equal to 1, you just substitute in this formula x is equal to n square plus 1, that is equal to 1 square plus 1, that is equal to 1 plus 1, that is equal to 2. The first number we got here, that is 2. If you just substitute n is equal to 2 in the given formula, that is 2 square plus 1, that is equal to 4 plus 1, that is equal to 5. The second number we got here is 2. So if n is equal to 3, you just check after here, 3 square plus 1, that is equal to 9 plus 1, that is equal to 10. What the third number we got here? 10. So the numbers in the set is, here he was given that is 2, 5, 10, 17. 2, 5, 10, 17. Here also in the answer, we got these numbers, right? 2, 5, 10 and next we get 17. That's why he was taking as the set builder form, x is equal to n square plus 1 is the formula which is used to get this set. N belongs to natural numbers and n is less than or equal to 4. I think you understand this form, this box. By using of this, by the knowledge of this box, we can solve this, do the sums and try the sums. Okay, next we will continue this 29th page, do this. From the do's, okay, that is do this, page number 29. So the first sum is, list the elements of the following sets. So these sums are in set builder form. We have to convert this into the roster form, that is listed form. The first sum he was given that G is equal to set of all the factors of 20. So what are the factors of 20? In which tables it was multiple, right? So what are the factors of this 20? 20 in first one table, 20, right? One table. So two tables, So is 3 table is multiple is the factor of this 20? No. 4, 5 table, right? Just like that in 10 table, okay, just like that in 20. So these are the factors. These are the factors. So what are the factors? The factors of this G is equal to set of 1, 2, 4, 5, 10, 20. These are the factors of 20. It is a solution for this first sum. Second sum, that is F is equal to the multiples of 4 between 17 and 61, and also which are divisible by 7. So first of all, we have to write this multiples of 4. Solution, multiples of 4 or 4, 8, 12, 16, just like this, right? Just like this. These are the multiples. And divisible by 7. Divisible by 7. Okay, divisible by 7. What are the numbers which is divisible by 7? 7, 14, 21, 28, just like this. Okay, but between 17 and 61, what are the multiples? Multiples of 4 between, just like this you have to write here also, multiples of 4 in between 17 and 61. Then the set is, so after 17, what are the multiples of this 4? That is 20. Okay, 24, 28, 32, 36, 40, 44, 48, 52, up to 61, no? 56, 60, up to 61. Enough, right? So again, the divisible by 7. Divisible by 7 between 17 and 61. These are after 17, that is 21, 28, divisible by 35, 42, 49, 56, 63. Up to 61, no, it's not enough. Up to 56 it is enough. What are the common elements in these both two sets? Look at here, 28 is repeated here and also 56, right? In the both the sets we have to satisfy both the sets. In the question, the multiples of 4 between 17 and 61, these, and which are divisible by 7, this one. What are the common elements in both 28 and 56? That's why the final answer F is equal to set of 28, 56. That's it. It is the answer. I think you understand this one, right? And the third one, S is equal to X colon X is letters in the word madam. Okay, S is equal to, already said, madam is the word, the letters we have to take from this, that is M-A-D-A-M. But we know that in the introduction part we already said to you, we already recollect that the repeated terms has to be write only once, that is M. It is 2 times. I am writing here only once. That is A also repeated 2 times. That is only 1. That is D. That is the answer for this third question. Fourth question. P is equal to X colon X is a whole number between 3.5 and 6.7. What are the whole numbers? Firstly, whole numbers means 0, 1, 2, 3 and so on, right? Whole numbers in between 3.5 and 6.7. What are the whole numbers after 3? 4, 5, 6. That's it. It is the final answer. Okay. So in between 3.5 and 6.7. So 6 also we can write here. Why? Because in between. Okay. So next, second Roman. That is, write the following sets in the roster form. In the roster form we have to write this set. The first one he was given here. B is the set of all months in a year having 30 days. 30 days. For the easy manner we can identify this like this, right? It is January. When it looks up, right, it is 31 days. It contains 31 days. January, February. February already we know that is 28 or 29 days, right? So don't write this February. Then March 31. April. So you just write B is equal to April. April. May. June. So June. July. Again you have to count this one on. So August. Come back. September. November. September. October. November. December. So leave it. Only 4 months we have that have only 30 days. 4 months in a year. Okay. So second question. P is the set of all prime numbers smaller than 10. So P is the set of all prime numbers smaller than 10. P is equal to, so set of prime numbers means 2, 3, 5, 7, 11 and so on. These all are the prime numbers, but less than 10. So P is a set of which is less than 10, hence 2, 3, 5, 7. Enough. It is the final answer. Because less than 10. So what is the third sum? X is the set of all colors of a rainbow. Colors of a rainbow. So X is equal to, we know that all colors of a rainbow or Vibzior. Vibzior means violet, indigo, blue, green, yellow, orange, red. So we have to write in the set, that is V, I, B, G, Y, O, R. It is Vibzior. It is a set of all colors in a rainbow. Okay. Now we will go to third question. Do this. So in the third question, what he was given that A is a set of factors of 12. A is set of factors of 12. So how can we find this factors of 12? So 12 is equal to, in one table 12 times, in two table 6 times, in 3 table 4 times, in 4 table 3 times, in 6 table 2 times, in 12 table 1 time. So these are the first numbers are the factors. So the set of A is equal to, what are the factors of 12? 1, 2, 3, 4, 6, 12. It is the first set A. Which one of the following is not a member of A? Which is not a member antunnadu. So here the first one is 1, second one is 4, third one is 5, D option is 12. Is 1 is there? Yes. Is 4 is there? Yes. Is 12 is there? Yes. It is also the factor of, but it was not a factor of, it is not a factor of 12. So our answer is this one. Okay. So try this in the same page. Try this. Page number 29. Look at here. The first question. What is the first question? Write some sets of your choice. You just write your choice, whatever the set you want, involving algebraic and geometrical ideas. Whatever the set you want, you just write. Okay, you just write. In the first question, your choice, you can write any algebraic and geometrical ideas. So I'll choose that is B is equal to set of triangles, all types of triangles, equilateral triangle, right angle triangle, scalar triangle, acute angle triangle, just like this. Okay, you can write whatever the algebraic ideas you have. You just write. C is equal to, I want to write some quadrilateral also, quadrilaterals also, that is rectangle, square, all quadrilaterals and trapezium, rhombus and parallelogram. So I write these two. You can write as your wish. Okay. For the second question, look at here. Here he was given that the matching. You have to match this 1, 2, 3, 4 to ABCD. Okay. So look at here, the roster form. These all are the roster forms, means listed forms. We have to choose the set builder form for these sets. So PRINCAL. So D is the option. Why? Because P is repeated. No, P is repeated. That's why he was written only once. I is also repeated 2 times. That's why he wrote only once. Just like which one? So remaining. Okay. So this is matched to D. You just write in your notes also this matching. Okay, make your notes for this matching also. Just I am showing here only. Okay, so for the second, that is 0. Okay, here look at here. So x colon x is an integer. X plus 1 is equal to 1. For which number you have to write here? 0. 0 plus 1 is equal to 1. That's why you just match these two. Second one is matched to C. So look at here, 1, 2, 3, 4, 6, 9, 18. What are these numbers? These all are the divisor of 18. Positive integer and is divisor of 18. So these all are the factors, divisor or factors, whatever you want. So in one table 18 is multiple. So 2 table, 3 table, 6 table, 9 table, 18. So it is a divisor, means it is a factor of 18, factors of 18. Okay, 3 comma minus 3. So if you substitute this 3 in this, 3 square. 3 square means 9. 9 minus 9, 0. So just like that, minus 3 whole square. minus 3 whole square minus 9, that is equal to minus of minus plus 3 square means 9, 9 minus 9, that is equal to 0. So that's why you just match these two. Okay, I think you understand this one also, right? Next we entered into the first exercise, that is 2.1. Okay, let us start to exercise 2.1. So in this 2.1, these all are very easier sums, you can do by yourself. Why? Because already I explained this, do this, try this and all, think and discuss in your textbook. But I'll explain in the brief manner, you can do in your notes by yourself. Okay, in the first Roman, which of the following are sets? Justify your answer. The collection of all months of a year beginning with J, that is January, June, July. Yes, it is a set. We can write these months, right? We can write these months, then it is a set. The collection of top 10 most talented writers of the world. Everyone have their own choices, right? So that's why it is most talented writers of the India, we can't judge. So it is not a set. It is not a set. Not a set. So team of 11 best cricket batsmen of the world. How can we judge? Everyone have their own choices, no? So not a set. Not a set. The collection of all boys in your class. Yes, you can write all the names of your class. Yes, it is a set. Okay. The collection of all even integers. Yes, even integers means we can write these all even integers, that is 2, 4, 6, just like this, right? Yes, it is a set. In the second Roman, A is equal to 0, 2, 4, 6, B is equal to 3, 5, 7, C is equal to P, Q, R. Then fill the appropriate symbol, belongs to or not, does not belongs to. Ikkada you have to fill in the blank. Okay, 0 dash A, you have to write this belongs to or does not belongs to. Is 0 is there in A? Yes, hence belongs to. 3 is 3 and C. Is 3 is there in C? No. 3 is there? No. Does not belongs to. Just like that you have to fill this second Roman. Then third Roman, you have to express these words in the symbols manner. Express the following statements using symbols. The elements X does not belongs to A, means X does not belongs to A. You have to write just only symbol, just only symbol. It is very easier, no? So you have to write this all remaining. This fourth Roman, state whether the following statements are true or false and justify your answer. You have to justify your answer also. True or false you have to write and also justify. So 5 is does not belongs to set of prime numbers. Set of prime numbers means how we have to write this solution. Set of prime numbers. Set of prime numbers means, so set of primes 2, 3, 5, 7 and so on, right? Is 5 is there? Yes, 5 is there. So 5 belongs to set of primes. But he was given that is does not belongs to set of primes. It is false, right? Yes. Then second sum, S is equal to 5, 6, 7. What he was given? 8 belongs to S. Is 8 is there here? No, right? It is false. Why? Because what is the justification? Why? Because 8 is not belongs to set S. So third one, minus 5 does not belongs to W. W is a whole numbers. Whole numbers which starts from 0, 1, 2, 3 and so on. Is negative numbers is there in the whole numbers? No. Hence minus 5 is does not belongs to whole numbers. Yes, it is true. It is the justification. It is the justification. What I explained to you, that is the justification. You have to write in your notes like this. Okay. Fourth question. 8 by 11 belongs to Z. Z means integers. But this number is in the form of P by Q. It's not an integer. It's not an integer. So integers are only -2, -1, 0, 1, 2 and so on. The positive numbers, positive integers and the negative integers including 0. But there is no P by Q forms. Hence 8 by 11 belongs to Z is false. Yes. So in the fifth Roman, so write the following sets in a roster form. Listed form we have to write here. So B is equal to, the first one is B is equal to x colon x is the natural number smaller than 6. Smaller than 6 means natural numbers is which starts from 1, 2, 3, 4, 5, 6 and so on. So smaller than 6 means natural numbers. B is equal to smaller than 6 means. So 1, 2, 3, 4, 5. That's it. Okay, less than 6 means we have to write like this up to 5. So second answer. So C is equal to x colon x is a 2-digit natural number. 2-digit natural number such that the sum of the digits are 8. So 2-digit natural number and sum of its digits are 8. Means C is equal to so 17. Why? Because 17 means the sum has to be 8, right? 1 plus 7, 8. So comma 26. Why? Because 2 plus 6 is equal to 8. The sum has to be 8. Okay. Next 35 means 3 plus 5 is equal to 8. 44 because 4 plus 4 is equal to 8. Just like that. You just reverse these numbers. 53 comma just like that. 62 71 comma and 80 is also there, right? 8 plus 0 8. That's it. It is a set. The final answer is this one. So third one, that is D is equal to x colon x is a prime number which is divisor of 60. Divisor of 60, right? So third sum, that is x colon x is a prime number which is divisor of 60. What are prime numbers? Prime numbers are 2, 3, 5, 7, 11 and so on, right? In that the divisors of 60. What are the divisors of 60? In these numbers only 2 is the divisor of 60, 3 is the divisor of 60 and 5 is the divisor of 60. It is a set which is divisors of 60. Okay. And the fourth one, 7 is not the divisor of 60. 11 is not the divisor of 60 and remaining all the prime numbers which is not divisors of 60. Only these three are divisors of 60. Okay. Then fourth one, E is the X is an alphabet in better. B-E-T-T-E-R. So the repeated terms has to be right only once, that is B. E is repeated 2 times, that is 1. T is repeated 2 times, that is once. R. It is a set of E. Okay. Then sixth Roman. Write the following sets in the set builder form. Set builder form we have to write. The first one is what he was given, 3, 6, 9, 12. Just look after here. These all are the multiples of 3. Yes, multiples of 3. So how can we write in the set builder form? X colon x is the multiples of 3 which is less than 13. Which is less than 13. X is less than 13. Okay. So second one. So second one, 2, 4, 8, 16, 32. So these numbers, just look after here, just carefully look after here. 2 to the power of 1, 2 square, 2 cube, 2 to the power of 4, 2 to the power of 5. You can write these numbers as this, right? So look after here. How can we write this set builder form? X colon x is the powers of 2, and this power, in the power of this 2 have natural numbers that is less than, that natural numbers is less than 6. Okay, and the third sum, that is 5, 25, 125, 625. Just look after this, just like the above sum, right? That is 5 power 1, 5 square, 5 cube, 5 to the power of 4. These are the powers of 5. So x colon x is the powers of 5. Powers of 5. And it is x colon, that is less than 5. The power is less than, x is the less than 5. In the power there is only 4, that is less than 5. And the fourth sum, 1, 4, 9, 16, 25 up to 100. These numbers can be written just like this: 2 1 square, 2 square, 3 square, 4 square, and so on, 10 square. These all are the powers of natural numbers. So how can we write this set builder form? X colon x is a powers of natural numbers, but that natural numbers x is less than or equal to 10. Okay, x is less than or equal to 10. Equal to 10 means 10 is also there, that's why I wrote this less than or equal to. Okay, so natural numbers. So now we entered into the 7th Roman. 7th Roman. So write the following sets in the roster form. In the roster form we have to write this one. So in the 7th Roman, the first sum is a is equal to x colon x is a natural number greater than 50. Greater than 50 means 51, 52, and smaller than, but smaller than 100. So 53, and smaller than means 99. This is a set for the listed form of this first sum. Okay, greater than 50 means 51, 52, 53, and less than 100 means 99, 98, just like that. Not 100 and not 50. Okay, second sum. B is equal to x colon x is an integer, x square is equal to 4. Here he was given the condition as x square is equal to 4, x is equal to square root of 4, x is equal to plus or minus 2, that is x is equal to plus 2 comma minus 2. Hence B is equal to set of plus 2 comma minus 2. It is a set for, it is a solution for second sum in 7th Roman. And the third sum, that is D is equal to x colon x is the letter in the word, is the letter in loyal. D is equal to L O Y A L. So repeated terms has to be right only once, L comma 0. It is the final answer, right? Now it is the last answer, last question for you for this episode. So eighth sum, it is a matching, right? Look at here, 1 2 3 4 1 2 3 6 1 2 3 6. What are these? Choose the correct answer, right? Prime numbers. So 1 is not a prime, it is not there, so it was not here. So look after here, natural numbers and divisor of 6. Natural numbers which is divisor of 6. Divisor of means factors of 6. Factors of 6 means is 6 is a 1 is the factor of 6, 2 is the factor of 6, 3 is the factor of 6, and 6 is the factor of 6. So match this 2. Okay, so 2 comma 3, these are prime numbers. Look at here, x colon x is a prime number and is a divisor of 6. In the prime numbers 2 comma 3 is there, hence these two match. So it is easy to identify, that is D, the letters in the word of this mathematics. So match these two. So remaining only one is there, 1 comma 3 5 7 9, these all are the odd natural numbers smaller than 10. So match these two. Okay, right. So dear students, we finished this first exercise of this sets chapter. You just carefully write your notes in a perfect manner, make your notes in a neat way. Today I finished from the first page of this sets. Do this all. You just complete it. I ticked here. You just, if you have any doubt, you just write like this. Do this. Page number 26. Do this. Think and discuss. Page number 27. Do this. Page number 28. Do this. Think and discuss. And 29. Table. Do this. Try this. And exercise all sums. You just finish off these notes. Tomorrow I'll start from the for the introduction of this second 2.2 exercise also. Okay. Thank you.